out to you, and then we're going to jump right in. I don't think y'all are going to struggle too much with this. There might be a couple of problems that are a little confusing, but I think for the most part, y'all are ready for this. And you will definitely be ready by the end of the day, the class day. Definitely. Okay, so this is our unit over arithmetic and geometric sequences, which we've obviously been talking about over the last 2 weeks. We hit it real hard last week, and I think you guys, did really well with it. So, again, this review is very, very similar to what you're going to see on the test. So if you look at this test and you're comfortable with it, or this review and you're comfortable with it, you're going to be just fine when it comes time for our actual test. One thing I want to remind you is, remember, I did not waste time trying to show you guys a third formula. I showed you one formula for arithmetic sequences, and I showed you one formula for geometric sequences, and then we utilized our calculator to do anything else with these particular sequences, as we'll see in just a minute as we're working through this. So just remember, we are only dealing with the first and the second equation, the one for geometric and one for arithmetic sequences, all right? So right off the bat, they ask us to do 2 problems where we give the first 5 terms of the sequence. And there are 2 different types. There's the ones that we call recursive, and then there's ones that we call explicit. This one right here is recursive. Can you remind me why? What does it do? It actually has 2 things that represent to you that it's recursive. Does anybody remember what they are? The first thing it does is it gives you a first term. See how it says a sub 1 equals -1? So right off the bat, it's telling you your first term, right? So that's one indication. Explicit formulas don't give you a term. They don't have to tell you anything, okay? The second thing, and the biggest key, the one that you got to recognize, is recursive will include this a sub n minus 1. Y'all remember what we said a sub n minus 1 represents? Anybody remember this? A sub n minus 1 represents your previous term, right? In fact, when we were going over this, I told you, when you see a sub n minus 1, I would prefer you not even say in a sub n minus 1. When you see a sub n minus 1 in your equation, I would prefer you say previous term. That way, when you look at this problem right here, instead of going 2 times a sub n minus 1 minus 5, I'd rather you go like this. 2 times your previous term minus 5. That's what it means. So if I want to find my second term, I got to do 2 times my previous term minus 5. Well, what is my previous term? -1, right? They gave it to me. So what's 2 times -1? What's -2 minus 5? -2 minus 5. -7. So my new term is -7. So what if I want to find my third term? 2 times my previous term minus 5. Well, what is my previous term? -7 now. So 2 times -7? -14 minus 5? So my new value, my new term's value is -19. Now how do I find my fourth term? 2 times my previous term minus 5. 2 times -19? -38 minus 5. -43. And then finally, my fifth term, 2 times -43, -86 minus 5, -91. So those are my first 5 terms of this recursive formula. Here's how recursive works. It takes the previous term and it makes some change to it. Okay? It relies on the previous term, a sub n minus 1. But then we move straight over here to this one, which we call explicit. Now I want you to notice a couple things. Did it give me my first term? No. Did it put a sub n minus 1 anywhere in the equation? No. This is explicit, not recursive. So do you remember how we deal with explicit? If I want to find the first term, what do? I plug in the term number. If I want to find the 47th term, I plug in 47. So here's the way I do this particular problem. If I want to find the first term, plug 1 into n. So 1 squared plus 7. Well, what is 1 squared? 1. What's 1 plus 7? 8. So my first term's value is 8. Does everybody understand that? So how do I find my second term? How do I find my second term? 2 squared plus 7. What is 2 squared? Can you help me out a little bit more? I got one person up here saying if that person got some help, we could do this a lot quicker. 11. Third term, 3 squared. 9 plus 7, 16. Fourth term, 4 squared. 16 plus 7, 23. And then finally your fifth term, 5 squared, 25. 25 plus 7, 32. So please understand the difference between recursive, how to find the first 5 terms, and explicit, how to find the first 5 terms. And again, I guarantee you tomorrow you're going to see 2 problems, just very similar to those. Okay, no tricks. It'll be straightforward, just like this was. Questions about those 2? Let's keep cruising then. The next question says to write an explicit formula that can be used to represent the sequence below. So I'm going to need your help with your calculator. So if you don't have your calculators open, get them open. All right. So there are 2 types of equations we've talked about writing: arithmetic and geometric. Okay. So what I usually do is I look at this and I say, which one does this look like, arithmetic or geometric? Which one does it look like to you guys that it might be? You don't know? All right, well, let's just start with one. Let's try our common difference first. Remember how to find the common difference? Second term minus first term. Second term is 1/3 minus first term 1/2. Somebody type that into the calculator for me real quick. 1/3 minus 1/2. And tell me what you get. So I'm going to check to see if I'm subtracting 1/6 over and over again. I know that's what it does from the first to second term. Let's check it from here. Type in your calculator, 1/3 minus 1/6. 1/3 minus 1/6. What do you get? Huh? 1/3 minus 1/6. What do you get? 1/6. You get 1/6? Is that the next value here? So is this thing arithmetic? No. So I'm going to check geometric. Common ratio. Remember, common ratio, second term, divided by first term. So 1/3 divided by 1/2. Somebody help me out there. 1/3 divided by 1/2. All right, so we're going to check now to see if this thing is doing what with 2/3. Not adding it. It's common ratio we're checking. We're seeing if it multiplies by 2/3. So do it with me. What's 1/3 times 2/3? 1/3 times 2/3. Is it 1/4? What'd y'all get? 1/3 times 2/3. 2/9. 2/9. Is 2/9 the same thing as 1/4? No. So what does this mean? It means it's not arithmetic or geometric. So it's not like either of the ones we've written so far. In fact, this goes back to the first lesson that we did. Remember in that very first lesson, we had to come up with the sequence? We had to write the explicit formula? We had to think it through. We had to struggle a little bit and find what it was doing every time. That's what we got to do here. So two things. One, it's explicit. Do I have to say what a sub 1 is? No. We go straight into the equation. And here's my thinking. Are y'all with me? Why are you sitting like a weirdo? Here's my line of thinking. I want to look at this particular equation, and I want to think, when I plug in 1, my first term, I get 1/2 out of it. When I plug in 2, I get 1/3. When I plug in 3, I get 1/4. When I plug in 4, I get 1/5. When I plug in 5, I get 1/6. What's not changing? The top number, right? Every time the top number is what? So I'm going to go ahead and do, I know the top number has to be 1, but what's happening on the bottom every time? First term was 2, second term was 3, third term was 4, fourth term was 5. It's adding 1 to whatever your term number is. How do we define our term number in the equation? Now, a sub n minus 1 is calling on the previous term. If we're just talking about the term number, we just say n. So we're going to make what change to n? Plus 1. So a sub n equals 1 over n plus 1. Okay? Now, in my opinion, that's the hardest problem on this review. It's the hardest problem on the test. But, with that being said, I promise that the problem on the test is no harder than this one. If you saw this one, you'll see it. Okay? Now, number 4 is a very simple problem. Okay? It's the one problem where you have to write a recursive formula. So please remind me, what's the first thing you need to remember about writing a recursive formula? What do you got to tell the people who are going to see it? You got to tell them your first term, right? You got to define your first term. So what do we say to do that? To do that. We say a sub 1 equals 3. Done. Now, the equation is going to be a sub n equals, they always are, a sub n equals, but because it's recursive, the second thing I need to remember is what has to be in my formula. What calls on the previous term? You got to have a sub n minus 1 in the formula. So now all we got to do, guys, is we got to see what is it doing to your previous term. What does it do to 3 to get it to 8? What does it do to 8 to get to 13? If you notice, it's adding 5 every time. Adding 5, adding 5, adding 5. So my recursive formula is a sub 1 equals 3. A sub n equals the previous term plus 5. Now listen, I promise you that tomorrow on the test, the recursive formula you have to write, it's doing one thing. See how this one's adding 5? It might be subtracting 4. It might be multiplying by 2. Okay? But it'll be doing one thing. You'll be able to tell, I think, real simply what it's doing. Okay? Questions? All right. So that's it. Everything else is formula. Everything else on this test is formula driven. Okay? Everything else is formula driven. So let's go on down and we'll just keep rolling. So number 5 and 6, it says describe it as arithmetic, geometric, or neither. If it's arithmetic or geometric, we need to state the common difference or the common ratio. So when I look at number 5, and I hope you guys do this too, I look at it and think, does this look more arithmetic or does it look more geometric? Because if I'm going to check to see, I'm at least going to check to see which one I think it looks like the most. So what does this look more like to you guys? Arithmetic or geometric? Anybody got an opinion? Okay, if no opinion, then let's just start with common difference. And then if that's not right, we'll go to common ratio. All right, so common difference. Second term, what is that? Minus first term. What is 4 minus 1.5? 2.5. So let's see if this thing's adding 2.5 every time. What's 4 plus 2.5? What's 6.5 plus 2.5? There you go. It sure is. This one is arithmetic. The first thing I checked worked. So my common difference is positive 2.5. And that problem's done. Okay? The one on the test tomorrow will be just as easy as that. So scroll over to number 6. Does this look more arithmetic or look more geometric to you guys? Does it look more geometric? Okay, then let's start by finding the common ratio. Again, if it looks more arithmetic, start with common difference. If it looks more geometric, start with common ratio. If you don't know, just pick one and start. So common ratio is second term, that's 3 over 8, divided by first term, that's 3 over 4. So type that in your calculator, 3 over 8 divided by 3 over 4. 1/2. 1/2. So we want to check to see if we're multiplying by 1/2 over and over again. Guys, what's 3/8 times 1/2? 3/8 times 1/2. So does that match? What's 3/16 times 1/2? Does that match? So this one is what? This one is geometric. So therefore, it has a common what? Ratio of 1/2. Or 0.5, right? 0.5 would have been fine. So there you have it, guys. Very simple, very straightforward questions. Y'all understand? Okay, let's keep cruising then. Unless y'all need that up there for a minute more. Okay, let's keep on moving along. Number 7. Number 7, it tells you it is a sequence. How do I know? Well, it says find the formula for the sequence. It is a sequence. So here's my question. Does that look more arithmetic to you or more geometric? Does it look more arithmetic or geometric? Does it? So let's just start then with common difference. Let's see if you're right, Trevor. So I'm going to take the second term, -7, and I'm going to subtract the first term, -13. Well, remember, minus the negative turns into positive. So that's -7 plus 13. What is that? So let's see if this thing's going up 6 every time. What's -7 plus 6? -1 plus 6? Ah, got it. It was arithmetic. My common difference is +6. So now what are we doing? We're trying to find the formula for it and what a sub 42 is. So let's start with our formula. The formula is, for an arithmetic sequence, it's given tomorrow. Okay, you don't have to memorize it, even though I think most of you guys probably have it. It's a sub n equals a sub 1. What's a sub 1? -13 plus, open parentheses, n minus 1 times d, which y'all just said is 6. Bring the -13 down, because what's the first thing we got to do? Did I hear someone say distribute? You were right. 6 times n, 6n, and 6 times -1. All right, everybody remember how we're going to write the formula? We always start with the variable. That's the 6n, isn't it? And then we combine these like terms. What's -13 minus 6? -19. So my formula is 6n minus 19. And that is done. So last thing, how do we find a sub 42? A sub 42. We are simply finding the 42nd term. So we plug in 42. So down here to the bottom, I'm just going to write it. It's 6 times 42 minus 19. So 6 times 42 minus 19 equals? So there's both my answers. Both of my answers for number 7. Turn pirate for a second. There's both my answers. All right, questions about that one? Okay, look at number 8 here. Does it look more geometric or does it look more arithmetic? No doubt about it. There's one just in-your-face thing. Look what it's doing. Positive, negative. positive, negative. Can you subtract something consistently or add something consistently and it go back and forth between positive and negative? No way. This has got to be a common ratio. So let's just double check. Second term is divided by first term. So right now it looks like my common ratio is -2. Let's see if we keep multiplying by -2. What's -16 times -2? Positive 32. The negatives cancel, right? What's positive 32 times -2? Bingo, found it, okay? So this is definitely geometric. So my equation is a sub n equals a sub 1 times my common ratio raised to the n minus 1 power. Remember the beauty of geometric sequences? When I write the equation, they cannot be what? Starts with an S, ends in amplified. They can't be simplified. Look, this is it. So we go write that in here. Now, listen to me, because I can't say this enough. People still keep making this mistake. It's not I prefer you not multiply 8 by -2. It's not that. You are not allowed to multiply 8 by -2. Don't do it, okay? Don't go, oh, well, I'm going to make that -16. No, you just missed the problem, okay? You are not allowed to multiply before exponents. So we leave it. 8 times -2 raised to the n minus 1. That's my equation. And what do I do if I want to find the 10th term? Plug it in. 8, open parentheses, -2, close parentheses, raised to the 9th power, or 10 minus 1, right? Y'all notice the 9th. So you're going to type that in for me, right? And you get -4,096 is my answer. Done. Okay? So there's the first 8 problems. Any questions? We got 8 more. Let's flip it over to the back. Number 9 and 10, still formula driven. Okay, look. They give you enough information for what kind of sequence? What kind of sequence? They give me enough information for an arithmetic sequence to find a sub 1. So guys, all we're going to do is we're going to use our formula for arithmetic sequences. What is that formula again? A sub n equals a sub 1 plus n minus 1 times d. All right, so we're finding a sub 1, right? We're finding a sub 1. So what do they give me? They give me a sub 14. So we're plugging that into a sub n, right? A sub n, we're using a sub 14. Well, what is a sub 14's value?
15.
So we're going to plug 15 right here. We don't know a sub 1, do we? But do we know n? We just use what term? A sub 14. A sub n. N is 14. So we use 14 for n. Do we know d? 9. So look, we've got everything we need to know to find that missing piece. A sub 1 plus, guys, what is 14 minus 9?
13.
Type in your calculator. What's 13 times 9? 13 times 9. So if I know that 15 equals a sub 1 plus 117, can I solve for a sub 1? How? Subtract 117. So type in your calculator. 15 minus 117. So my first term's value is -102. Okay? Questions with that? Pretty easy, right? Okay, keep cruising along here. Number 10. They give me enough information for what kind of sequence?
Geometric.
To find R. So remember, here's my equation. A sub n equals a sub 1 times R to the n minus 1 power. So let's see what they give me. They give me a sub 1 is 2. So I'm going to replace a sub 1 right here with 2. And then they tell me a sub 5 equals what? So we're going to replace a sub n with a sub 5. Well, what is a sub 5's value? So we're plugging 4802 right here. And now listen, isn't that a sub 5? A sub n is 5. So we're going to plug 5 up here as well. So look, we've used the same equation for geometric sequences that we've done for all geometric sequences, but this time we just don't have r. We have a sub 5, we have a sub 1, and we have n as 5. So here's how I simplify this thing. 4802 will equal 2 times r to the 4th power, right? 5 minus 1. So guys, how do I get r to the 4th power alone? How do I isolate r to the 4th? Divide by 2, right? So what's 4802 divided by 2? So 2401 equals r to the 4th power. So I want you all to go to your calculator, and I want you to go to math. Math. Y'all see cube root in math? But y'all see 4th root? So does that mean I can't do 4th root? No, I can do all roots. How do I do all roots? I use number 5. Math number 5, and when you hit that button, it looks like this. Most of the time, because you've been using your calculator, it inserts ANS right here. That means your answer from the previous problem. It plugs it in there. So you just need to scroll up there and replace that with a 4. Okay, just replace it with a 4. It'll be the 4th root of, and then type in your 2401. The 4th root of 2401 is, so r equals 7. R equals 7. And there you have it. They're formula driven. You use the formula to find a missing piece. And listen to me, guys. On your test, on number 9, guess what you're trying to find? A sub 1. On number 10 on your test, guess what you're trying to find? Your common ratio. I'm not going to change this test. I'm just changing the values on it. I want you to find these certain things, so just rest easy in that. Okay, go to number 11. Given the sequence below. So we know that's a sequence. Okay, what does it look more like to you guys? Arithmetic or geometric? So I agree with Trevor. I think it looks more like an arithmetic sequence. So I'm going to double check to see if it follows a common difference. Well, that second term, 1, minus first term, 6. 1 minus 6 is negative 5. Let's see if this thing keeps subtracting 5. What's 1 minus 5? Negative 4. What's negative 4 minus 5? Bingo, we found it. It's arithmetic. So listen, guys. I step back now with this arithmetic sequence, and what do they ask me to find? They're asking me to find S sub 22, right? We're trying to find the series, the sum of this series, all the way through the 22nd term. So instead of teaching you guys a formula for this, what did I say we do? We do big E, right? For all of my terms from the first one to the 22nd term. That's what we're going to do. That's how I taught you guys to do this. So what do I need to do this? I got to have my equation. And don't we have a formula for arithmetic sequences? A sub n equals a sub 1, 6, plus n minus 1 times d, negative 5. What have I said over and over again we got to do first? Negative 5 times n, and negative 5 times negative 1, positive 5. Always start with your variable term, that's negative 5n. And what's 6 plus 5? So my equation is negative 5n plus 11. So we're going to type right into this equation, negative 5x plus 11. So it's going to find the sum of this whole sequence, all the way from the first to the 22nd term, for that sequence, negative 5x plus 11. So when you type that into your calculator, what does it tell you?
Negative 1023.
Yep, negative 1023 is my answer. Questions about that one? Anybody? Okay, let's go to the next one then. Or do I need to hang out there for a second? Okay, let's go here to number 12. Does this look more like a arithmetic or geometric sequence? Definitely. Look what it's doing. Positive, negative, right? So the first thing I'm going to check to see if it has a common ratio. So that's second term, negative 200, divided by first term, 800. What's negative 200 divided by 800? Negative 1/4, or negative 0.25. So let's see if we keep multiplying by negative 1/4. Guys, what's negative 200 times negative 1/4? Negative 200 times negative 1/4. Is that right? Okay, then this one's definitely geometric. So here's my equation, guys. A sub n equals, remember how easy this was? A sub 1, 800, times r, negative 0.25 or negative 1/4, raised to n minus 1, right? That's how easy you can write this formula. You can't do anything with it, that's the formula. So how do we find S sub 9? How do we find S sub 9? How do we find the sum of this thing through the 9th term? Come on, guys.
The E.
The big E. From the 1st to the 9th term, for 800, open parentheses, negative 0.25 or negative 1/4, close parentheses, raised to the x minus 1 power. That's how you do it. So type that into your calculator. Make sure you put everything inside the original parenthesis, and let's see what our answer is. When you get it, say it.
Negative.
I got 640. Is that what you're at? 640?
Yes.
Are y'all with me? I don't know. I just don't feel
I
like
got a bunch of numbers.
I don't feel the vibes.
I've been answering you all day.
I don't feel all the vibes of everybody.
I got 640.
All right, 640 is right. Check what you did, Margaret,
Work.
because it should be 640. All right, moving along. Right? Ready?
No.
You're not, for real?
Oh, that's what I did.
Okay.
I forgot to turn off the alpha and I clicked 1 and it put Y.
Gotcha. Okay, so this problem, you are going to just type it in your calculator. Remember, this whole thing needs to be in your original parentheses. So it's going to do the sum of all the x values from the 2nd term to the 9th term, and then you type it in just like you did the last one. Here's the one thing I want to say about this. As you're typing it, I'm going to write the answer that I got, and then you can check to see if that's what you got. I got negative 25,220 over 6,561. Now, how many of you guys understand what that number is? Exactly, I don't either, okay? I couldn't tell you. I could kind of give you an idea because 6 goes into 24 4 times, so it's got to be close to 4, right? Right? Negative 4?
Negative 3.84.
All right, here's the point. In a case like this, if your answer mathematically is something you don't understand what that number even is, change it. If you go to alpha, y equals number 4, and change this to a decimal, like Trevor said, the answer is negative 3.84. How many of you guys understand that number better than negative 25,220 over 6561? Every one of you know that better. You know that number better. So I would prefer you change it, okay? Now go over here to number 14, type that in real quick, tell me what you get. If you write 42 on your test, you'll get full credit. on this problem. But if you expand it, you'll get extra points. So let me remind you, what does it mean to expand it? Expanding it just means tell me what they did to come up with this answer. Tell me what this button in your calculator is doing to come up with this answer. It's finding the sum of how many of the terms? From the second through the fifth term for this equation 3 times n. So what does that mean it's doing? Okay, well, how would it find the second term? How would it find just the second term? How would you find the second term for this sequence? How would I just find the second term for that sequence? Wouldn't you plug it in? Wouldn't you go 3 times 2? And we're doing that all the way through what term? So how would I do the third term? 3 times 3. How would I do the fourth term? And how would I find the fifth term? So what is the sum of all of my terms from the second to the fifth term for 3n mean? It means I'm finding all of these terms when I multiply them or plug them into the equation, and then I do what with them? I add them up. That's what it means to expand. Show what the button in your calculator is doing for this problem. It's doing 3 times 2, 3 times 3, 3 times 4, 3 times 5, all the terms from the second to the term, and then it's adding them all up. Okay? That's expanding it. That's understanding what the button in your calculator is doing. If you do that, you'll get extra points on the test. If you just put 42, you'll get full credit. Okay? Last two problems are word problems. Bricks are stacked in a pile with 42 bricks on the bottom and 9 bricks on the top row. Sorry. Each row has 3 fewer bricks than the row below it. Pause. 3 fewer. What does that mean? 3 less. It means it's doing what every time? Subtracting 3. Guys, is that a common difference or a common ratio? It's a common difference of -3. So is this thing arithmetic or geometric? Definitely arithmetic. Here's what else this tells us. This is the second trick to this problem. If we're subtracting 3 every time, what is a sub 1? Is it 42 or is it 9?
42.
It's 42. How do we know that our first term shouldn't be 9 here?
Because you can't subtract 3 if it's 42.
Exactly. If my first term was 9, my bricks would be having to go up 3. But they're going down 3, so a sub 1 is 42. Because that's really all we need for this problem. Look what it says. It wants me to write a formula to represent the number of bricks and then find the 7th row. So here's my formula, guys. A sub n equals a sub 1, 42, plus n minus 1 times my common difference, which is -3. 3 fewer bricks. What do we say we do? First, you got to distribute, right? What's -3 times n? And what's -3 times -1? So when I finish this thing off, that's -3n. And guys, what's 42 plus 3? So my equation is -3n plus 45. -3n plus 45. That's my equation. That's my formula. Now, what is the 7th row? How do I find that? You plug in 7. So you're going to go -3 times 7 plus 45. So how many are in the 7th row? 24 bricks. 24 bricks. Does everybody understand that problem? Okay, last one. They give me a table. Remember how I said you interpret.
Are you good?
How you interpret a table when we're comparing it to sequences. The first row, the first column right there, it's your term number. That's first term, second term, third term. The seats, that second column, is representing your actual sequence. So what's the sequence doing every time? It's adding 2. It has a common difference of positive 2. So here's the deal. Here's what this thing is asking us to do. It's saying if this pattern continues for 12 rows, will there be enough seats for 500 people? So don't we need to accumulate all the seats? Don't we need to do this big E thing? For all the rows, from which row to which row? From the first row to the 12th row, for the equation that goes with this problem. So guess what I gotta do? I gotta write an equation. So A sub n equals A sub 1. Do we know the first term's value? 30 plus n minus 1 times d, 2. Distribute d, so bring the 30 plus down. 2 times n is? 2 times negative 1. Combine your like terms, 2n goes first. What's 30 minus 2? So my equation that represents this sequence is 2n plus 28. So if I want to figure out if there's enough chairs, I'm simply going to do the sum of all of my rows from the first row to the 12th row for the equation 2x plus 28. So take a moment and do that. The sum of all the rows from the first to 12th for 2n or 2x plus 28 is what? 492. Are there enough chairs for these people? No. In fact, we're 8 short, right? Not enough. There's not enough. So, anyways, that is very similar to what your test will look like tomorrow. I'm telling you, there's no tricks. I don't like to trick you guys. I like to give you what you're going to get. So if you are comfortable with all the things that we just did, then you are good to go. If you're not comfortable, then my suggestion, and I would suggest this even if you are comfortable, study it, get really comfortable with it, because tomorrow the questions are going to be in the same order. They're going to be the same types. You're going to be doing the same things. It's just going to have different numbers, okay? I'm not going to try to trick you. This is what I want you to know. This is what you're going to have to test. Any questions? Yes, ma'am.
Would you, when we take the test tomorrow, put the equations on